How's it going, everyone? My name is Brendan. Today, I'm going to be walking through a capabilities tour of the Athena platform. Let's jump in. So we're going to be walking through everything on the iPad today. We'll be doing some more live demos with the actual UI this week. And to orient ourselves, for folks who maybe have not heard of us or need a refresher, we're Athena Intelligence. We consider ourselves a decision intelligence platform. Another phrase I've heard thrown a lot around lately is co-pilot for data. I think that's true, and I like that one as well. You can think of us as a modern decision-making engine that leverages both human and machine. So we are not AGI, and we are not a software management or workflow tool like a Jira. We're some symbiosis between the two. Hopefully it'll make a lot more sense when we get through some of the demo today. Most of what we're looking at is going to be for a more technical audience. We'll have some less technical industry and use case tours again later this week, and we'll post those as well. This one just a bit more less formal to get an idea of what we're working on and some of the more recent stuff. So we're going to split this into roughly two parts. Part one is going to be right here on the left side. We'll start with basically connecting data and modeling that data. And the right-hand side is going to be our capability set. All this is stemming from one of our core primitives, which is the causal model. So we're going to show how A, we get there, and then B, what that enables. And then just to highlight a couple of those capabilities to entice people early, we have a few here. One is causal forecasting. And the example we're showing is a demand forecasting and shaping use case. The second example will be scenario planning. Feels a lot like prediction or what if analysis. Third thing we'll be reviewing is a impact analysis. So system-wide, how do different variables or features or mechanisms interact, and how do you interpret that? And then the last is going to be an attribution workflow, excuse me. This is both attribution for single points or spikes in your data, as well as entire channels or entire distribution changes. Why did our sales decrease by half last year? Or this particular day, we saw a decline in our visitor rate. What was the reason for that? So these are some of the attribution workflows. There's probably about 10 or 15 more we're not going to be talking about. I want to keep this under 30 to 45 minutes, so we'll start with those four. So walking through a new customer deployment, first off, we need data. The causal models and most of the algorithms are, again, based on data you bring. So in majority of cases, this is split into two buckets. The first bucket is going to be pre-built integrations. So if you use any of these platforms, and just to highlight a few, these are things like marketing platforms, ERPs, customer service, tickets, finance, looks like order management systems, social, and analytics systems. Again, there's probably about 100 more that we can connect into. In majority of these cases, we've already created some pre-built integrations. What this means is you log in, you connect, type in your credentials, and within about 24 to 48 hours, we have prepared, ready, and available tables. And because of those tables are ready, downstream capabilities are essentially unlocked. In cases where maybe you've already done the integration work yourself, your team's a little bit further along in their data journey. Maybe you have a CSV or an Excel file that you have already maybe done by hand. You can also connect these or upload these directly, your BigQueries, your Redshifts, your Snowflakes, all the traditional systems we know and love today in the ML ops and data engineering world. Upon either a few pre-built integrations or a few of the source systems being connected, what you'll see when you log in is going to be a slew of green source tables dropped in. If you're using a pre-built integration, you'll see a lot of the hygiene, aggregation, and dirty work in order to, again, get to a source or an end table that is useful. We like to think of these as our canonical or our golden tables, which we'll use for the modeling and reporting side. Again, if your team is already has a DBT instance that's churning away, we're happy to connect directly into it. In cases where that's not available, we've again done a lot of that hard work to allow you guys to get access immediately. Great. So now we've reached some base state of cleaned unified data. Again, I wouldn't discount this first section. A lot of demos and a lot of software I've seen in the market spends all their time talking about capabilities, and they expect all this to either have been done or essentially not going to be done at all. And in those cases, after 1 to 3 months, there's no value being taken out of the software, just because the data in, bad data in, it's bad data out. Great. So taking a look from where we left off, our cleaned and unified table. Two things that we see in most platforms today, which we emulate. We think they're necessary, but nothing new here is going to be our reporting capability, as well as just basic search. We did add some pretty interesting stuff that I'll talk about here in a second in search. But across the reporting functional stack, these are mobile optimized, so to work on your phone while you're moving. These are near real time. So we can do hour increments, 15-minute increment updates, depending on those source systems. And these are configurable. So the reports that this customer cares about and looks at is going to be Google Analytics, 2 ad platforms, order management system, as well as a roll-up. And they're looking at attribution primarily for this table. What I will say as well is most of the downstream causal workflows will actually produce a resultant table or are accessible via an API. So the reports are not just the raw data that you have, coming from your source systems, but a lot of times it's derived data that is shown side by side in order to reach quicker decisions. Part 2 of just, again, getting access and democratizing the ability to get access to your data in one single pane of glass is going to be our search and ask capability set. This is new and kind of fun. So if you search with the prefix /Athena, it's actually going to use an intelligent search. So it'll look at all those tables that you've prepared in the previous step. It'll formulate a SQL query that answers that, and then it'll run that query and produce the resultant table here. And not only will it produce that table, but it'll also create 3 or recommend 3 additional follow-up questions. A typical workflow that an analyst will do is ask a question that'll produce an answer that's helpful for them, and they'll think of what are the next 3 questions I want to ask. This helps you in that journey. Again, thinking of this as a human machine team or an AI-assisted co-pilot for your data. All of this is, again, available in the raw format, so you can see exactly what the system's querying. You can see exactly the results. You can save this down. You can edit this. All of this, again, helps us provide transparency of what's actually happening. So that way, teams that are technical can dive into the inner workings, or teams that want to become more technical and understand how these things are being produced are able to learn with an AI assistant. All right. So just a quick recap. We have our data in from a few source systems. We can report on it. We can ask basic SQL questions of it. Those 2 workflows that we just talked about, I like to think of as majority of software that's kind of hitting the market, and it's all historical, right? These are questions: what were our sales last year? Find me how many units we've sold of this product last Black Friday. Most questions that people want to ask of their business are either questions to better understand the business. So, excuse me, these are why did our sales look the way they did last year? How could we have doubled them? Or what risks do we have for the following year in our supply chain? Or what will happen if I were to reprice this particular service or product in this way for my customers? So all these questions, again, are not answerable directly using your SQL lookups and joins. There's a lot of ways to kind of cut the data to get to a somewhat similar answer, but we'll look at here shortly how by building, again, this primitive, the causal model, and then the capability set that comes out of that makes for a much, much simpler ability to ask questions of your data, specifically the questions that are the why questions and the what if questions. Great. So again, leaving off with one of those tables, we'd imagine, we have 3, 4, 5 features or columns, fields. And in this stage, we're actually going to be developing the causal model. So this is, again, one of the human plus machine teaming workflows. In this workflow, what we're doing is we're describing the process by which the data is produced and what happens in the world. You can think of, any one of these columns. Machine won't know right off the bat what it is, why it is the way it is. So by actually describing this graph, A, you help it learn at a much quicker rate, and B, you constrain some of the more anomalous behavior. And we'll go over what an anomalous behavior would look like in correlation-based systems or some of the deep learning approaches, and why this is different. Great. So the causal model that was created by this customer includes Google Ads, Facebook Ads, Google Analytics, and an order management system. So again, as we spoke about earlier, as you connect more and more systems, you'll get access to all of them in one unified view, and then you can build more complex workflows. So this workflow that we're looking at includes these nodes, the fields again. So you can think of this as maybe we spent $4,000 on Google Ads. That is going to drive impressions, clicks. Those clicks are driving people to the store, this website. Maybe they don't directly go to the store, but they come back later. And then those store sessions lead to people purchasing, and all those purchases are counted up in total transactions for this particular business. I think one interesting call out here was in this workflow, we're not just looking at the interaction between Google Ads, again, people seeing the ad, clicking on the ad, visiting the site once they've clicked on it, but also people that are seeing the ad, and then there's a causal line underneath here somewhere that goes to direct. So what this is saying is someone spent a bit of money, we've showed some ads, maybe 100,000 people have seen the ad, and a certain segment of them did go and click on it and get sent to the page. Another segment didn't. They saw it. Later that day, they actually came back in their heads and said, hey, that was interesting. I want to go to the site. And that's actually what we're capturing with this line underneath here. So you're able to capture some of these more nuanced workflows. In this example, we're actually not using any conversion tracking metrics. So it doesn't rely on conversions data or any of the privacy policy user capturable information that a lot of the attribution workflows require nowadays. So again, this is going to be very specific to the domain expert and business use case. This is a marketing attribution causal graph. And again, some of the other ones that we'll take a look at are going to be product journey, as well as supply chain risk management. So once we've gotten to a first draft on our causal model, we're then able to use that model in any one of our workflows. Let's start with our impact analysis. So in the example I'm going to show here, let's just plot yeah, I'll start with this. So in the example that I want to show for impact analysis, let's quickly orient ourselves to the graph that this business is operating in. So this business use case is going to be for a product journey, right? So this is marketing spend, driving views, add to carts, checkouts, purchasing, how many they purchased, sales, and then throughout that entire journey, things that are interacting with someone's ability to move through that customer journey is going to be pricing it, discounting, right? Those are impacting all the variables here. And all this is saying is, as you change prices, people are viewing the page less, adding it to cart less, checking out less or more, depending on the business. And same with that discount rate or some promotion. And then some KPIs we're measuring are purchase rate, checkout rate, add to cart rate, and AOV. So in this model, we're going to be asking the impact analysis question on price. Yeah. So it's going to be, what is the impact of price on purchase rate? And at first glance, if we just plot these two, this is what we'll see. And it's not very useful as is, right? So we have price down here, and then we have that purchase rate. And what we see is they've priced products a ton of different ways, and there's a lot of different purchase rates at different price ranges. Looks like they've never priced anything in this range here. But we can imagine the underlying mechanism could look like this. It could look like this. It could look like this. It could look like this. We really don't know. And the reason we don't know is because there are so many factors influencing the purchase rate, right? Like we can imagine they've discounted a ton differently, which influence this, which influence this, which influence this, which influences the purchase rate, right? They've marketed differently. So they did a ton of marketing last year, let's say influenced here, and that influences there, right? So there's, unless you've done perfect A/B tests at all stages of your business, there are so many different factors that have changed over time. You can imagine this varying over time, that it's hard to ascertain what is price and purchase rates relationship. And as this graph grows much larger, it gets almost completely unwieldy and impossible. And again, you need this causal model. And then this is the primitive that we can actually suck all that noise and that variance to understand, what is the true impact of just price on purchase rate. So running our model, we can see just that. What we're seeing here with the confidence interval is going to be, if all things equal, if the month never changed, if the products look the same, if everything were the same, this is your customer's price elasticity curve. So for the customers of this business, as you raise the prices from roughly 0 to 20, it looks like they are going to purchase less. At 20, they're roughly going to purchase the same. And obviously out here, we have a little bit less variance. We can see with a larger interval, and likewise here. But roughly speaking, the price elasticity of this customer segment is pretty tight between 0 and 20. And given this information, we're actually able to take it and take this and go and either reprice something or keep this in the back of our heads as we're operating in our day-to-day. In this example, we ran the impact analysis. It produced this graph. And then interestingly, there's this interpret button. And what we're doing is we're actually passing GPT-4 this graph, and we're saying, hey, can you help me understand it? And it actually comes back. So this is a pretty new capability that we just dropped. I'm not going to read through all of it here, but it does result with, the results suggest that despite the general downward trend when the average price and purchase rates increase, this could be due to a shift in the target audience, wherein the customers who can afford more expensive items might be more inclined to make purchases at higher prices. It could also be attributed to perception of higher quality or exclusivity with higher priced items. So it actually makes a pretty reasonable interpretation for why this is the way that is. And we can take that and run with it, or we might have some other thoughts. But I would say just by having someone kind of sitting next to you and giving you their 2 cents, and this is improving significantly over time, it's a huge benefit and huge help for people who worked with the ChatGPT systems. Just having someone to bounce ideas off of. A lot of times you come up with better ideas yourself. Great. So I'm not going to spend too much more time on impact analysis, but you can imagine for any nodes within any network, you're able to basically take any two pairs and say, hey, how do these things relate? And really ascertain what is the impact of those two things, removing all the variance from everything else and getting these very reasonable lines, curves like so. Another one, which we're not going to spend too much time on, is a marketing saturation curve, which was pulled out from the model we saw here. Okay, these next two, I'll try to go a bit faster. I'm a bit slow on time. These are two of the prediction capabilities. So again, if we think about impact analysis as at a system-wide level, what is the mechanism that's at play? That's what impact analysis is doing, it's helping us understand a system. Whereas the two down here are scenario planning helps us run historical counterfactuals. So what would have happened? And it also allows us to do forward predictions. And then if we stretch those forward predictions out over time, that's just going to be a forecast. So let's take a look. So we're going to be using the causal model we saw from before on products in the product journey. And that is, again, that same that same causal model is behind everything we're looking at. So the example we have here is for that product expiration, you're now not only able to, from the impact analysis side, look at what mechanism is happening, grabbing two pairs, but in this example, we're able to perturb any one of these and then understand if I were to shift my marketing spend on this product up, if I were to shift my discount rate up, change my price, somehow drive more traffic to the page, what happens to my outcomes? What happens to my sales, my units sold, my orders, my checkouts, my add to carts? And using the same UI, instead of changing your inputs and seeing how your outputs change, you can change your, let's grab a new fun color, change your targets, so your outputs, so you can move sales to, let's call it 8,000, and say, how do I configure my inputs in order to reach this target? Not only this target, but I also want, let's say, my units sold to be, or let's actually configure this target. I also want my price to be 25. So I can set those two as base state. And what'll happen under the hood is these will all move in order to realize this outcome. So obviously you probably have to discount a bit more. You have to spend a bunch more marketing, which will drive a bunch of traffic. All in all, you can set as a goal set and then find the inputs, or you can say, given these inputs, find out what my outputs would be. And I think a lot of us are probably asking the question, well, then what happens if I set, an 80,000 target? Is it just going to find a bunch of random inputs? That definitely won't work. Bit technical here, but we have an anomaly score. This is effectively, you can think of this as the probability or the chance that given the historical information we have about your business, that this is possible, that this has happened. So you can set these crazy targets. It'll find a best potential solution. If you were to hit that, here's how it could happen. But it'll also give you some reasonable doubt factor to say, that's just very untrue or very impossible given the circumstances. Or it might say, this is super reasonable. Maybe set a higher target. So that workflow, again, finding out what's a good sales target, setting it, finding the inputs that are going to create that, or vice versa, given we've already planned to discount in this way, spend this way, this will be the resultant views. We plan to price this way. You can, from a finance perspective, have some idea of, what are our sales or what is our demand forecast going to be, given some stuff might be set in stone and locked up. Exciting. Cool. Let's move on to forecasting. I'm not going to spend too much time here. We can just think of forecasting as our scenario planner, but stretch it out over time. And that's exactly the view that we're looking at. So in this example, again, using those same causal mechanisms, we're basically drilling down to a skew, taking the three inputs and adjusting them as we see fit. Maybe move them up and down. And then we're seeing the resultant forecast where blue is going to be our historicals and red is going to be our forecast with our confidence intervals. And we can see historically, have we changed our prices? Looks like two small occurrences. We dropped them from 30 to 27. And, what does traffic look like? Can't see it here, but it's something like this. We can imagine. So maybe there was some seasonality. Maybe we spent differently in marketing. But going forward, we are going to set the demand drivers to say, what if we can hit this target, keep the price here, keep our discount rate here, marketing here, then what would our resultant demand forecast be? And we can actually change these values to say, if we put our price at 31, we'll see the entire UI move up. It'll go to 31. And then additionally, you'll see how this adjusts the forecast. Again, think of it as scenario planning, just with a more easy to understand and see time element. I like to think of this not only as forecasting, but as shaping. In many cases, we're not trying to predict the future, we're trying to shape the future. So in occurrences where, we have a certain amount of inventory we're trying to sell out, we want to shape our demand in order to hit that inventory number. Or if we have a restock coming, we want to shape the demand in order to, meet that restock with some just-in-time or near just-in-time workflow, and then do a repurchase. All those, again, are capable using that same UI. Awesome. Last but not least, so we've looked at prediction and what if scenario planning, something like Sims for your business. You guys played that game back in the day. And then in the other scenario here, we have impact analysis, so understanding the system writ large. In attribution here is going to have a similar flavor to impact analysis, in that impact analysis is how do you understand the system, again, at like a system-wide level. Attribution for this specific view that we're looking at is going to be point attribution, or what can you tell me why this specific thing happened? So why did we see a spike in sales? Why did visitors not come to the store this day? Why did one specific outcome or metric happen? And in the lens that we're going to look at it, we're going to look at it through a new use case, which is an email marketing use case. So in the email marketing use case, quickly taking us through our inputs, we have, are we sending the email in January, February, March? Who are we sending it from? Todd. We sent it on a Wednesday, and Todd's email is todd@gmail. Campaign, maybe it's an A/B test. Maybe it's a other type of campaign for whoever Todd runs. The subject category, we see a ton of stuff in here from sales subject line, tons of emojis, maybe a seasonal, right, or some holiday subject line, and then actually how many people are sending it to. We're not going to review segmented, but all these factors, in this case, 1, 2, 3, 4, impacts the click rate. So when someone opens it, and then what month you're sending it, from who it's from, the day of the week, email, campaign, subject category, these all influence someone's ability or proclivity, again, to open the email. And then once it's opened, their likelihood to actually click through. So obviously in these businesses, people are interested in when something happens, like a super low click rate or super high click rate, or a super low open rate, a super high open rate. Why did it happen? Was it because Todd sent it? Was it because Friday is our best day, or let's see, January is our best month? Was it a really great subject line? What actually drove that person to open? Or maybe our attribution is going to be for the click rate. So using this causal model, again, with data coming from the email system that you've connected, and let's say we have that data set and we see, there's a particular line here. Let's call it last Thursday, and your click rate was 29%. And for people in email marketing world, they know that's a very high click-through rate. So we might see that. We might say, okay, Athena, can you help us ascertain why? And in doing so, this UI is going to pop up. It's about 30 seconds to run. And what it'll do first is it'll provide you a high-level overview for, again, this is click rate, the 4 upstream nodes, so the 4 potential causal factors, 5, excuse me. It'll provide a relative attribution score. So it believes the reason for that 29% click-through rate is probably because of the amount of people you sent it to, total count unique people. And then second to that is the day of the week you sent it. Then, a bit lower here is going to be what kind of campaign you had, the subject, and the month you sent it in. And again, like we saw before with the impact analysis, we're actually going to query GPT-4 in order to help us provide some reasoning for this. And it comes up with a pretty nice answer. I'll skip to the explanation for one because I think it's the best one. And what it also calls this out as, its number one reason here is if you send, in this example, we only sent it to 17 people, to get a 29% click-through rate, only a few of them have to open it. And it kind of overinflates the click-through rate. It makes it seem like the entire email is phenomenal, where this customer, I think, typically sends on the order of 50,000 per campaign. So when you've only sent out 17 so far, maybe it was a very small directed order to a very, very small group that are already on a listserv, that click-through rate looks phenomenal. So again, using this causal attribution mechanism, we're very quick to determine the click-through rate is a combination of the relatively small number of people receiving the email being sent on a favorable day of the week, and to a lesser extent, the month that the email was sent. All very clear for the teams to take and then make use of. Alrighty, so that's probably all we got for today. I'll do some more videos this week where we actually dive into the UI, and we'll walk through a lot of the examples we just walked through actually in the user interface, but I wanted to kind of give us a high-level overview of what's happening, why it's happening, and then we can do industry and use case deep dives. Great. I will see you guys all later.